guys. Hello. Learning about exponential functions.
There you go. All right, here we go. Exponential function is when you have a base that is bigger than 0. It can't be a negative base and it can't be a 1. And your exponent is an x or a variable of some sort. So here's some examples we're going to evaluate by hand. So when you put a 4 in for x, you get 2 to the negative 1. So do we all remember? So how do you get rid of the negative exponent?
Multiply by its reciprocal.
You're going to change the base to its reciprocal, and then it'd be to the first power, which would still be 1/2. Okay? So negative exponents, you take the base, right as a reciprocal, the exponent becomes positive. Second one. Again, we have a negative exponent here. So only the base that the negative exponent's attached to is going to move. And it's going to be squared. So you should be able to evaluate these by hand. Okay, this next one is to a rational exponent. So what's another way of saying to the 1/3 power? What else could we write it as? Anyone remember? Cube root, right? So that would be to both. So we would say the cube root of 1 over the cube root of 7. Well, the cube root of 1 is just 1, right? Now, who remembers we cannot have a radical in the denominator? Okay? So, if we're in a cube root, how many things do we need to have before we can cancel to a regular number? 3. We need 3. So we're going to have to put in another cube root 2 more 7s. Does that make sense? So we wrote that? So now I have the cube root of 3 7s would equal, that's just a regular 7 on the bottom.
Oh, because it cancels out.
Because it cancels out. So we have to do the same thing on top. So up top we would have the cube root of 49. We want a regular rational number in the denominator. Okay? Because it's a cube root, you got to multiply it by a cube root of 7 times 7. All right, last one. 4 raised to the negative 3 over 2. So I have a negative exponent. I write the reciprocal of the base, and the exponent changes to positive. With me? In this rational exponent, which number is the root? The 3 or the 2? This is how I remember. I'm a tree. Where are my roots? On the bottom. So which one's the root? The 2. So you can take the square root of 1/4 and then raise it to the 3rd power. So what is the square root of 1/4? Take square root of the top and the bottom. What do you get?
1/2.
1/2 raised to the 3rd power. Cube both the top and
1
the bottom. Okay? So little by little you can do this in your head, right? Maybe with a piece of paper, pencil. All right. We all good? Moving on. Let's just graph one of these because I know you can do this. Let's pick some negative 2, negative 1, 0, 1, and 2. If I have 2 to the negative 2nd power, what would that equal? 1 over 2 to the positive 2nd power, which is 1/4. 2 to the negative 1 power is 1/2. 2 to the 0, is what? 1, right? 2 to the 1 is 2. What's going on with these y values? They are multiplying by 2, aren't they? They're doubling. Why? Because the base is a 2. If the base was a 3, you'd be multiplying by 3. Okay, that's the growth factor. It's how it's growing. So we can graph those. Negative 2 1/4, negative 1 1/2. The board is way off. This is an asymptote, isn't it? Horizontal asymptote. So remember, don't cross that, don't touch it. So that's an example of exponential growth. The second one is an exponential decay. Why? How do I know that?
Because the bottom is 3.
Yep. The base is less than 1. If the base is a fraction or a decimal between 0 and 1, it's going to be growth decay. Not growth decay, exponential decay. Because when you multiply by something smaller than 1, it shrinks things. Okay? Do I need to graph that one? Are you guys good? Moving on. So know the difference between exponential growth and decay. Look, it's a slide all by itself. So this one's exponential growth. What's the domain of this? All real numbers. You can take the, you can put any exponent on a number. Okay, but again, b has to be greater than 1 for it to be growth. The range is not all real numbers.
Equals 0.
It's got to be above 0. What asymptotes do you have? 0. Can we say it a little bit more specific? Jared? Y equals 0. It's a horizontal asymptote, so it is y equals 0. Intercepts. There are no x-intercepts. This is never going to touch the x-axis in this example. But the y-intercept is 0a. Is it even? Does it fold across the y-axis? Is it odd? Does it rotate around the origin? It's neither. In behavior, you guys are still, some of you are struggling on the writing of it. As x goes to negative infinity on this side of the graph, what's that height approaching? 0. And on the right side, as x gets to infinity, the height is going to infinity. Okay? So make sure you know those properties. Guys, if you know the graph, you know the properties. Okay? You should be able to jot them down. The decay properties, does the domain change? Does the range change? Does the asymptote change? Intercept didn't change. So all these things are the same. In behavior, though, changed. It flipped. Okay? We're only at 8 minutes, guys. So quick. Good. Okay, find a function in the form of CA to the x that goes to the points 1, 1, and 2, comma 1/5. So anytime you're writing an equation and they're giving you points, you're going to replace the y and the x with those points. So in the first point, the y equals 1 and the x equals 1. That doesn't do a whole lot for me with just 1 point. Okay. So second equation, the y is 1/5 equals c times a to the second power. That makes sense? All right. There's a couple ways you can do this. So I'm going to show you one way. Math Excel might show you a different way. What I'm going to do is I'm going to divide. Because they're exponential, I'm going to divide the two equations. Okay? So, let's bring this guy. I'm going to put the one with the higher exponent on top. Let's just divide them. So what is 1/5 divided by 1? 1/5. What happens to the c's when you divide? They cancel. And when you divide like bases, you subtract the exponent. So this is just going to be a to the first. So I have nothing else to do. A equals 1/5. Okay? Then it doesn't matter which equation you take. I'm just going to take this guy. And I'm going to replace the a in this equation. And solve for c. So you're going to multiply both sides by 5. Or divide both sides by 1/5, either way. So now I have my c and my a, and I can go back and write my equation. And you're done. That make sense? So they're just basically c a to the x or b a, whatever letters they give you. It's just a basic exponential. Divide them. Find your a, and then plug it and find your c. Okay, let's try this guy. This equation's a little bit more involved because you have a plus sign here. So we're not going to be able to divide. We're still going to write our two equations, though, and just see what we can do. That's my first equation. And that's my second equation. You cannot divide these. If you divide them, things aren't going to cancel like they did before because of the plus sign. So, got to figure something else out. So look at it. The exponents are different, so you really can't subtract them. But is there some way I can simplify something here? What can I simplify?
A to the 0 equals 1.
A to the 0 equals 1. So in the second equation, I can find b is what?
2.
2. Everyone see that? So look for those things. So over in this other equation, okay. A couple ways you can do this, but the easiest way is to get rid of that negative 1/2. I'm going to raise it to the negative 1/2 power. That's going to cancel out that negative 2. We'll go to a 1. So a equals 4 to the negative 1/2. Make my exponent positive. And what is the 1/2 power, actually? The square root, isn't it? So what is the square root of 1/4? 1/2. Okay. So, just going to kind of play around with the equations to see if there's things you can solve. We're good? All right. Before we sketch this, I'm going to go and do this first. So I was at 3 to the x, and now my equation is 2 times 3 to the x plus 1 minus 1. What happened? So when you multiply by a 2 here, what does that do?
Stretch.
Vertical stretch. Because it's outside. What does the minus 1 do?
Shift to the right 1, down 1.
Down 1, because it's not with the x. Anything up here in this exponent position, that's a horizontal thing. So plus 1 with an x means left 1. So if it's happening up in the exponent area, that's an x thing. Everything else is y's. Okay? So inwards, we vertically stretched this by 2, went down by 2, or 1, left 1. Guys, when I drop this guy down 1, that changes my horizontal asymptote. So this is the line I'm going to skate along. Vertical shifts change those asymptotes. So if I'm looking at 3 to the x, I'm just going to put some points up here. Uh, 3 to the negative 2 is 1 over 9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3, remember, we're just multiplying by 3 here. So those are my original graph points. So we are going to apply the scale changes to them and the adding and subtracting things to them, okay? So the y, the vertical things, we are multiplying every y by 2 and subtracting 1. For the x, we are taking every x and subtracting 1. That's the transformation that's got to take place. So the x's are easy. X minus 1. So negative 2 minus 1, negative 1 minus 1, 0 minus 1. So those are my new x's. And my new y's. Multiply by 2 minus 1. So that's 2/9 minus 1 is negative 7/9. Multiply by 2 minus 1. 2/3 minus 1 is negative 1/3. Multiply by 2 minus 1. It's a 1. Multiply by 2 minus 1. Multiply by 2 minus 1. Those are our new y points. And then you can sketch. Okay? So negative 3, negative, see it's down here. Negative 2, negative 1/3. Negative 1, 1. 0, 5. And then 1, 17. So it's going to come along this axis. Easy breezy. We are not going to get the whole thing done in 20 minutes. I think I said 38.5, didn't I? We'll see where we are. We'll take a vote whether we continue or not. Just think tomorrow, all math excel.
We get to like 20 minutes of this, 18 minutes tomorrow.
Maybe.
We'd be stopping right now.
Here we go. So let's write the new equation. So it says y equals 2 to the x. I want to move it 2 units to the left. Where would that change take place? Up.
That's plus 2.
It's going to be x plus 2 up in the exponent position. And then 5 units up.
Plus 5.
Plus 5 here. So it's horizontal. It's going to be in the exponent area. So we're starting with y equals 3 to the x. We're moving 3 units to the right. So minus 3 up there with the x. And then reflected about the y-axis. So where's that negative going to go? Down in front or up with the exponents are? Up with the exponent is. Because it's a horizontal flip. If it was a vertical flip, if it went around the x or about the x-axis, you'd put it down in front of the negative 3. Okay, we are doing a vertical stretch by a factor of 2. So we're multiplying
By 2.
out front by 2. And you're shifting down 5. Everything was vertical there, so it's going to be all outside. Good. All right. Here are the exponent rules that I know you know. When you multiply by like bases, you add the exponents. When you divide like bases, you subtract the exponents. If you have one base or more than one base and you have an exponent outside, you apply that to every exponent inside with multiplying. If you're dividing, same thing. That exponent goes to both top and bottom. Anything to the 0 power equals a 1. The negative exponents you write as reciprocal bases with a positive exponent. And then we already talked about the fractional exponent. The bottom number is the root. You should already know those. They're in your head. You need those to do more things. Okay? But we already used a couple of them, right, when we were solving those equations? A to the 0 was there, and we subtracted exponents. Okay, I will come back in one moment. Simple interest, P times R times T. The interest equals the principal, that's how much you started with, times the interest rate per year in decimal form, times time, the number of years you borrowed it for. Okay? Very simple interest formula. It tells you the interest. Okay? Let's just define the interest. P means principal, R is the rate, T is the time. So let's try this one. Find the total amount in the bank, assuming $10,000 is deposited in a simple interest account. So the interest we make off of $10,000 deposited at an interest rate of 7.5% for 2 years. Just multiply it out. What do we get? $1,500, right? It asks how much is in the account. So you've got to take the 10,000 we started with plus the 1,500. Okay, that's how much we have total in the account. So make sure you're reading with Math Excel. Are they asking for interest? How much is in the account? What are we doing? Okay. Very, very basic. All right. If you're compounding the interest. So simple interest is just every year they put the interest in. Compound, you still have the principal. It's 1 plus R, it's still a decimal. The N stands for how many times you are compounding a year. So if we do yearly, that's just a 1. Quarterly would be quarterly. How many quarters are in a dollar? 4 times a year. Semi-annually is twice a year. Monthly is, and daily we're going to go with 365. Okay. The N shows up in 2 places in the formula. It's under the R and it's multiplying to the T. Time is still in years. It's a little bit more complicated of a formula. So let's try a couple questions here. I guess I lied. I'm going to do this one. Compound interest. If it's compounded continuously, that's the same formula. Never mind. I meant to erase this. Watch this. There's the formula. Okay? Here we go. Assume that $5,000 is deposited in a 6.5% interest rate. Find the value of A after 1 year if the interest is compounded semi-annually. So the amount in the account is principal times 1 plus the interest rate as a decimal. Semi-annually, what's the end value going to be? 2. And then 2 times 1 year. And then you're just going to type that in your calculator. One big long line. Please don't chunk it up. Bad things happen. So this is giving you, what should I round to for money? The nearest penny. Okay? This gives you how much is in your account. So how much is interest if I wanted just the interest amount? How much is this different from the starting amount? 333. Yep. All right, so try the monthly one. See what you get. The amount is really, it's only like $4, $4.50 more. Basically, every time you compound the interest, you're making money on your interest. You're making interest on the interest. Because they figure out the interest after 6 months and they throw it into your account and then you make interest on that interest. That's what compounding means. Here, every month, if you go to your monthly statement on your bank account, your savings account, it'll show interest amount. And that gets added to your balance, so next month you're going to make interest on the interest. It's compounded. All right. Here you go. Continuous. If it's compounded continuously every nanosecond, it changes the formula very quickly. It's PERT. P is the principal still. E is that special number, irrational, 2.71, blah, 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 blah. Your calculator is going to give you. R is your interest rate, again, is a decimal, and T is time. So this is a very easy formula. Your principal, your E value, 0.06 for 6 years and 9 months. Very careful. What is that as a decimal? What is 6 years and 9 months? What part of the year is 9 months? What's 9 divided by 12? 3/4, right? 0.75. So the time is going to be 6.75 years. You put 6.9. Okay, so we have 9,000. Everyone know where the E is? It's the second function of your natural log button. And it'll automatically put these things in the exponent position for you. So you make pretty good money when you have it compounded continuously. And again, we are rounding it to the penny. So you made almost $4,500 in interest there. Okay. Make sense? Easy formula. So when it says compounded continuously, anytime things grow continuously, biology, things grow continuously, populations grow generally as a percentage for an annual or whatever. Continuous, PERT. We already did that one. This is just a natural exponential function. It's the same thing. It's a growth exponential function. 2.71 is bigger than 1, so it's the same function. Okay, just now. They normally call this the parent function for exponentials. So, how did this thing change? How did that change? I'm going to rewrite that a little bit. I want to say y equals negative e to the negative x plus 2. All I did was rearrange a little bit. So what did the plus 2 do? It goes up 2. What's the negative with the x do? Reflects it over the y. The negative out front also reflects it now over the x. So think about, this is the normal exponential curve. We are going to move it up 2, and then it's going to flip around the x-axis. And then it's going to flip over the flip over the y-axis, and we're going to flip it over the x-axis. So this guy, this is now going to be your thing here. Not bad face. Okay. My question is it going to shift first? You can graph that in your calculator. I'm going to make sure we got it. Darn it, it shifted it last. It reflected and then shifted. That's okay. Reflect. Reflect it upside down. And then it's going to shift it up too. So do the reflections first. That's what the graph looks like, the purple one. Okay? But you got to be able to name the transformations. It doesn't matter what the base is. The transformations are the same. Okay, guys. That's your model. This model, constant rate of increase or decrease. In 2008, the median price of houses in Miami was $190,000. Assuming a rate of increase of 3% a year, what can we expect the price of such a house to be in 2013? So let's write it down. .06 or 0.03 is the rate times. How many years have gone by? 2008 to 2013, 5 years. Since we're talking about prices of houses, I'm not going to include the penny. Okay. What would the price be if we are depreciating by 3% a year? So, for the growth, continuous growth formula, the K can be positive or negative. If K is negative, it just means a decrease. So you'll write the whole thing same, except it's going to be a negative exponent. Okay, so same exact thing, except we're going to put a negative here. So it's losing. A negative exponent will lose. Okay, so increase is a positive. Decrease, it's a negative K. Same formula. Good. I think we're good. Let's see what this last example is. I think we're going to skip it.
Just more.
I think we're good. Let me ask you this real quick. Each minute, we're increasing by 5%. We started with 25 bacteria. So we're adding 5%, so it's going to be 1.05. How many times did it change in 1.5 hours? Each minute is changing by 5%. So how many minutes are in an hour and a half? 90. You understand how you're going to have to write the formula? So pay attention to those changes in time. Okay?